Hi, fourth graders. Today we are doing Module 3, Lesson 18. And today we're going to find whole number quotients and remainders. And we're going to be doing a little bit of mental math today. So hopefully you have been studying those multiplication facts. All right, here we go. So first we're going to start by dividing mentally. So we're going to think about 50 divided by 5. Okay, so we're thinking about how much 5 divided by 5 is, and we know that's times 10. So 50 divided by 5 is 10. It goes in 10 times. Now we're going to say to ourselves, how much is 5 divided by 5? Well, 5 goes into 5 once. So now we're going to think about how can we do 55 divided by 5 mentally. Let's draw a number bond to connect the two original problems to this new problem. I can take 55 and break it into 50 and 5. Now, if I look at my last two answers, I have 50 divided by 5 is 10. 5 divided by 5 is 1. So 55 divided by 5 is equal to 11. Let's do the same thing with a couple more examples. Let's think to ourselves 90 divided by 3. We know that 3 goes into 9 3 times, so it must go into 90 30 times. 6 divided by 3. How many 3's will fit into 6? 2. So if I wanted to do 96 divided by 3, I would take my quotient of 90 and then my quotient from 6 and put it together for 32. Same thing. 80 divided by 4. Well, I know that 4 goes into 8 twice, so it goes into 80 20 times. 4 divided by 4, we know, is 1. So 84 divided by 4, we take the quotient of 80 divided by 4, which is 20, and the quotient of 4 divided by 4, which is 1, to give me a total of 21. Let's look at the application problem for today. Mallory's family is going to buy oranges. The Grand Market sells oranges at 3 pounds for 87 cents. How much does 1 pound of oranges cost at Grand Market? Well, what I'm going to do the read, draw, write. First, I'm going to think about what the problem is telling me. If there's 3 pounds for 87 cents, I want to know how much 1 pound of oranges cost. So I'm going to first draw myself a tape diagram. Here's what that might look like. 87 cents is my total, and I know that 1 pound, 2 pounds, 3 pounds total, so I have 3 equal sections, is going to be 87 cents. What I want to find out is the total for 1 pound of oranges. So I'm taking my total of 87 and dividing it into 3 equal groups. Pause the video here, and I want you to do the standard algorithm of 87 divided by 3. All right. When you do the standard algorithm for 87 divided by 3, it would look like this. 3 goes into 8 twice. 3 times 2 is 6. 8 minus 6 is 2. Drop down the 7. 3 goes into 27 9 times. 9 times 3 is 27 with no remainder. So 1 pound of oranges cost 29 cents. We're going to go back and do more practice with the standard algorithm in just a moment. So here's our concept development for the day. We're going to start by solving some division problems. The first one we're going to solve together is 57 divided by 3. So we're going to divide 57 into 3 equal groups. We're going to break 57 into tens and ones. So starting by dividing 57 into tens and ones. 57 is equal to 5 tens and 7 ones. Now when we divide it up, we're going to start by dividing up the 5s. Why are we going to do that? By the 10s rather. We're going to do that because we may have to unbundle them and regroup into the ones place after. So let's start doing that. I'm going to take one of them here, one here, and one here. Now I have 2 10s left over. So I'm going to need to take them and unbundle them in the ones place. Once I've unbundled my 2 10s, I've put 20 ones into the ones place with my 7 ones that were already there. And now I have 27 ones that I'm going to divide up into 3 equal groups. I went ahead and distributed that into 3 equal groups. I ended up putting 9 into each of those 3 groups. So when I look at what I have in one of the sections, in each section, I have 1 10 and I have 9 ones. 1 10 and 9 ones is equal to 19. So 57 divided by 3 is equal to 19. Now I'm going to go ahead and do another one. We're going to solve 86 divided by 5. We solve 57 divided by 3 by unbundling the 10s. We're going to try a more challenging problem. How many groups will we divide 86 into? Well, you can see that it's 86 divided by 5, so we're going to divide that into 5 equal groups. What's the first step? Well, the first thing we're going to do is break it up into 86, break it up into 10s and 1s. When we break 86 up into 10s and 1s, we have 8 10s and we have 6 1s. So first I'm going to start by distributing my 10s. So I'm going to put 1 here, 1 here, 1 here, 1 here, and 1 here. And now you can see that I have 3 10s that are left over. I'm going to have to distribute all of these 10s and unbundle them into the ones place. So my 3 10s are going to come over and become 30 ones. Now that I've unbundled my 3 10s into 30 ones, I'm going to add that to the 6 ones that were already there, and I have 36 ones that I'm going to need to distribute into 5 equal groups. So when I distribute my 36 ones into 5 equal groups, I end up with 7 in each group, and I still have 1 left over. So when I take a look at how much is in each group of 5, I have 1 10 and 7 ones, which is equal to 17, and I have 1 left over that hasn't gone anywhere, so that's 17 with a remainder of 1. Before we move on from this problem, I want to show using the long division or division algorithm to show how we recorded those distributed 10s and then the remaining 10s. So when we show with the long division, the division algorithm, it's going to look like this. I had 86, and I was dividing it by 5. First, we had 8 divided into 5 equal groups. There was 1 in each group, giving us 5 that we distributed. We had 3 10s that were left over. We brought those 3 10s over into our ones place, changed them in, giving us a total of 36 ones. Then we divided up our 36 ones into 5 equal groups. There were 7 in each group for a total of 35. We took that away. There was 1 left over, which gave us 17 with a remainder of 1. Now we're going to start thinking about this in terms of mental math. If we have the problem 74 divided by 8 and we want to solve it, we've unbundled the 10s and we've written remainders in the quotient. Now we're going to take a look at this. What's tricky here? Well, we can think of our 8 facts. And I'm thinking of an 8th fact whose product is close to 74. Can you guess it? Take a second and think and say it out loud if you want. 74 can be broken up into 72 and 2. One of my 8th facts is 9 times 8 is equal to 72. So therefore, if I think about it like that, I know that 72 divided by 8 is 9. And then my 2 also is the remainder. So we're going to do the same thing for a couple other problems. 87 divided by 9. Is there a nines fact that we could use to make this problem easier to solve? Let's see if we can do it by drawing a number bond. Now, what times 9 is going to give us close to 87 without going over? I can think of 87 breaking it up into 81 plus 6. I know in my multiplication facts that 9 times 9 is 81. So then 87 divided by 9 would be 9 with a remainder of 6. So let's keep going with the mental math. Our next problem we're going to do is 64 divided by 7. How can we solve this one mentally? Let's do the same thing and think about if we can think of a 7 fact that will get us close to 64 without going over. I know that 64 can be broken up into 63 and 1. I know that 7 times 9 will give me 63, and there will be 1 left over. Therefore, 64 divided by 7 is equal to 9 with a remainder of 1. Today, you're going to do your problem set, which is on pages 117 and 118. You're going to solve using the standard algorithm and check your quotient and remainder by using multiplication and addition. You can also do what we did before and use mental math to help you solve it. Your exit ticket is on page 119, and you're going to turn that into your teacher.